everybody, and welcome to another Desk of Lady Ada. It's me, Lady Ada. I'm at my desk. And tonight we're going to do a short and sweet one because I know you guys get holiday parties you're going to go to and maybe you have some Christmas presents you got to go buy. So we're going to do a special in honor of the new DigiKey special. Ooh, there's a DigiKey special for the holidays. You can get a red Metro. I'll hold it up. It's a red DigiKey edition of the Adafruit Metro, and it's available for $15, which is a really good deal. And it's like a high quality board. Do you want to go to the thingy and we'll check out the
Which
computer?
One do you want to go to?
Well, I thought we'd go to the computer. We'd talk about this. DigiKey electronics plus Adafruit. Save some green, get something amazing in red. Yeah. Everybody wants a red board this holiday. Yeah, if you go to Adafruit, blog.adafruit.com, it's the first link pretty much. Yeah. $15 limited edition Metro. Have a red and green holiday with DigiKey Adafruit Atmel. And there's like this cool little Ada bot. She's saving money and gets something amazing in red. And it has a little bit of my text. It has these nice photos. You know, the only thing that's a little sad is they don't show the back, which is I'm going to show it on the overhead. Because the back is the really cool part. So this is equivalent, it's completely identical in parts and layout and everything to the normal Adafruit Black Metro, except that it's in red. And on the back, we actually have all the DigiKey parts on it, so it's really cool, and it's in DigiKey red. So you want to just go straight to the tour?
Yeah, let's see the overhead.
This is the overhead. Okay, so here we are. So this is the Metro, and then this is the black one. So you can see it's really the exact same design, but it's in a lovely red. Give you a tour of this. So it's 2.7 by 2.1 inches. It's got 13 digital pins here, 6 analog digital pins, and then power pins, VIN, ground, 5-volt regulator, 3.3-volt regulator, reset, IRF. Over here is how you connect to your computer for uploading and debugging. Use any micro USB cable. So you can see you've got the indicator LEDs right here on the edge. This is really handy. So if you have a shield on top, because the shield covers up all the LEDs and buttons and stuff, you'll still be able to see the LEDs over here because they're on the edge, which I kind of like. And you've got green power, yellow for like the RX and TX, and then red, which tells you that the bootloader is running, as well as an indicator LED. And then another thing that I like is, the reset button's over here, so it's kind of handy. You can always get to it from like the side. And then another thing that I put on here is an on-off switch. So the on-off switch is for DC power. So let's grab a DC power jack. So if you're using a DC power or like a battery pack to power this, you can plug it in, and then from the edge you can turn it on. Or, oh, you know what? This is not plugged in. Sorry, my power supply is not plugged in. So let me get one of these that I can. It's hard to indicate that the on-off switch is working when it's not on. Okay, so you can power up your plugged-in DC power supply. And then you can turn a whole thing on and off. And this turns it off via a little P-channel MOSFET up here. So you really get like all the power is completely disconnected. So it'll depower VIN, 5-volt and 3-volt power supply. For the USB connection, I'm using an FTDI chip. These are got really good drivers, they're really solid. If you reset the board, it doesn't reset the USB connection, so you can reset and watch the program run from the very beginning. And it's got the 2 LEDs, of course, that you saw that blink RX and TX when data is received and transmitted. So the chip used on this board, the Atmega 328, doesn't have built-in USB capabilities. It just adds a USB to serial converter, and it just uses the bootloading and debugging and serial console. And then, you got the main chip over here at Mega 328. It's running at 5 volts and it has a 16 megahertz ceramic oscillator. You can reprogram it if you want with like a USB Teeny or an Atmel, ICE or whatever through the 2.3, a 2x3 ICSP header. Also got a nice power supply here. You got a pretty beefy SOT23 regulator for 5 volts, a SOT223 for the 5 volt, and a SOT23.5 for the 3 volt. Big capacitors, so you can run motors and stuff. And then what's really neat is over here, there's a little jumper. So if you want, you can change the logic level from 5 volts to 3 volts. You'd be overclocking the chip. So instead of running it at 16 megahertz 5 volts, you'd be running at 16 megahertz 3.3 volts. It's a little bit above spec, but Atmel chips are usually pretty chill with being overclocked. You can overclock them twice before really anything happens, and then they'll just start flaking out a little bit. So it's fine. I do it all the time. I'll just cut the trace, solder it, set it to 3.3 volts, and then I can talk to 3.3 volt sensors without any worry. It's got an auto power switch, so depending on whether you plug in DC or USB, it'll go with DC if it's available. And then I want to show the really cool thing. So on the bottom of the normal Metro, it's got this kind of cool modern design that Bruce Yan and Phil B did. But if you look on the bottom of the DigiKey Metro, we have a lot of space. So when I suggested that DigiKey carry the Metro, it's like, well, we want to have a special one. I'm like, well, how about we make one where on the bottom we have all the components that are used to make this. So I exported the bill of materials, and I found all the DigiKey part numbers. So let me see if I can autofocus. And lock. So you can see, I've got the PCE 3908 CT, and that's the 47 microfarad 25 volt electrolytic capacitor. We got the 500 milliamp PTC fuse. That's part number 507. 480-1-ND. So every single component, except for the micro USB jack, because I actually don't get those from DigiKey, is available here. So if you want to know what's the regulator, what's the USB serial chip, the ferrite bead, the Schottky diode, the red LED, the green LED, it kind of gives you a recipe on the back so you can make your own. This design went through FCCC testing. Got the DigiKey logo, and then on the bottom it even has a special URL that they made, digikey.com/metro. So you can get this for $15, and it's compatible with all of our shields, and it's, I think, a really good board. I designed it for the kind of stuff that we do at Adafruit. I use this board for all of the tester designs. We design a lot of testers, so we go through, we have to design every single week 2 or 3 testers. And so having an on-off switch, having the reset button over here, having the LEDs over here, having it use a micro USB jack, these are things in being able to change the voltage, because I have to constantly, some of our stuff is not quite 5 volt compatible, or there's for example, if I make a hat for a Raspberry Pi, it's a 3.3 volt device. I have to have something that can talk 3.3 volts, so I would convert the Metro to 3.3 volts to do the testing for that. Because it's a lot faster to test with an Arduino IDE than to test with a Raspberry Pi, just because microcontrollers are much faster than microcomputers. And do we have any questions from people?
No.
Do you have any questions?
What was the ICE thing you said?
Oh, it's an in-circuit emulator. So I believe it also does debugging, so you can connect it up and reprogram it. It's if you don't get USB Teeny, I don't remember the exact name of it, but Atmel has a bunch of different programmers and debuggers that use the standard 2x3 ICSP headers for the AVR family.
Okay. Next up, if you get this Metro board, how do you program it? Can you show?
Absolutely. So I will plug this one in, and I will start up. You can program it with, and here's the design, so you can.
I'll go to your screen.
Yeah, so here's the layout.
Okay.
So this is how I did the design for all the background. I have I have all the components, and I just typed them in, and then I created them as text, and I put them on the back. And this is in EagleCAD. That's exciting. Okay, so I use the Arduino IDE. You don't have to. You can program it with AVR-Dude and AVR-GCC natively. But just as an example, I will use the Arduino IDE because you can make it add support for it very easily. give it a second. So I recommend installing the board manager for all of the Adafruit boards. So I have the latest version. So Adafruit AVR boards, add support for Flora, Gemma, Bluefruit Micro, Feather, Metro. So that's what we're talking about here. Then you can, it takes a few seconds after you do that. Select the COM port, which is 76. And then you can select Metro. And then I'm just going to, for example, do the basic blank sketch. I'm going to make it blink a little fast, though. So I just upload to Metro. I have it on the verbose uploading. Okay, and then if we go to the overhead, you can see it's blinking. Yay, hold on, let me log. So it's that easy. And then you can also use the USB connection as a serial console, so you can like have it print using like printf even if you want to print sensor data or like logs of what's going on through the USB serial converter. It's so easy.
Okay.
This is totally worth $15. Also, you get it from DigiKey. They'll ship like in 5 minutes.
Yeah. Okay, so besides the on-off and the voltage change, what else? Go over the hacky things that you added.
Yeah, the LEDs on the edge.
Yeah.
Oh man, hold on. Lock the. I think I did it. LEDs on the edge, on-off switch, voltage regulator, voltage level adjustment. Beautiful silk screen. Uses an FTDI chipset instead of another Atmel chip. It's got a perfectly smooth bottom. It doesn't have, this version doesn't have through-hole headers. Although we have a version that if you don't want headers installed, we have a version that has no headers. And has a micro USB jack.
Okay.
That's a lot. That's like 6 things.
Yeah. Okay. What's the advantage of native coding with AVR GCC over an IDE?
Oh, that's a great question. So I actually learned AVRs using native AVR GCC. So the downsides of using native AVR GCC is you don't get the whole family of like Arduino compatible shields and libraries that are pre-written in the Arduino C++ thing. Although you can still import them into AVR GCC. AVR GCC is the compiler that the Arduino IDE uses. If you want to have full control over what your microcontroller is doing, like to the instruction, GCC will definitely get you closer because, for example, the Arduino IDE doesn't have a real-time operating system, but there are things that happen in the background. For example, when you do a serial print, I'm pretty sure as of like 106 or something, it doesn't print the whole string at once. It actually starts sending a character and it sends up an interrupt that when the character's done sending it, it'll kind of go through these interrupts and send them off. So you don't have control over that interrupt. Also, definitely timer 0 is used for the millisecond timer. So you don't get access to that either. And there's probably actually a couple other things that you can look at in the core that are quote unquote done for you. For beginners, it's really handy because like you just want to like print a string. You don't want to necessarily handle the detailed innards of like setting the baud rate and how many stop bits and the parity bit or whatever and even or odd of your UART. But AVR GCC will just, you can still use register definitions in Arduino. You can do that, but it's like you can't take away the fact that, I think, like, for example, the millisecond timer uses timer 0. Like, you can't undo that. So, it depends. Like, if you want to get the smallest code possible, like blinking an LED, for example, let me see, it compiles to 1 kilobyte of space, which is not that much space, by the way. But if you did an AVR GCC, it would be like 60 bytes because you don't have, you just set up the port, set the output, and then you'd maybe call a delay function, or you'd have your own little loop for delay, and then you'd go back and forth. So you could get it much, much smaller. You could definitely pack a lot more stuff in. But it's like you're going to have to do a lot more yourself. But some people prefer that. It's fine. Both are available.
Okay. Someone said they're going to overclock theirs 10 times and water cool it.
Well, it's not that it's going to overheat. A lot of times when people talk about overclocking, like a PC, what they're doing is it's actually the die temperature at the speeds we're talking about, like gigahertz speed. You need to cool it down because you're having problems because of the cooling. That's not. I mean, I guess I don't know exactly why PCs need to be overclocked. I don't know if it's like, oh, the die temperature has to be brought down and that's what's causing failure. What's going to cause failure for a microcontroller is, honestly, the tolerances aren't that. Like, let's say you have your ALU, for example, your arithmetic logic unit. There's some delay after you put in an instruction and you clock it. How long just from the transistors all going off, like every gate activating until your answer is ready. So let's say, I'm totally going to just use like big round numbers. Let's say it takes 5 nanoseconds to get your answer out of the ALU. Well, you want to clock it so that, and also, by the way, it depends on the instruction a little bit and like how many bits you're using. And there's a worst case, if you're using every ripple count or whatever. So instead of, you don't want to clock it at exactly 5 nanoseconds. You want to have your instruction take 10 nanoseconds because you're going to load in your data. You'll tell your ALU, okay, add these numbers or shift it or whatever instruction you want to do. And then you want to give yourself a little buffer time so that you can, it only takes 5 nanoseconds, but you'll have 5 nanoseconds where nothing's happening, but so you have a little bit of buffer, right, of like how long it takes versus, you get to the train station, a few minutes at a time, right? So when you overclock a microcontroller, what I think is the most likely thing that's actually keeping you from overclocking it forever is not that it's overheating. Like these things run so cold, like there's no heat sink, like there's nothing going on here. What happens is that when you overclock it, eventually there's some part of the processing unit that, it's taking 5 nanoseconds and you're clocking it at 4. So, you're trying to get the answer out of the processor faster than it can actually get the answer through the entire chain of gates because there is going to be some delay from gate to gate. It's very, very small, but you have a ton of gates and they add up. So that's kind of what's keeping you from overclocking forever. Now, that's just if you want to like clock this at like 50 megahertz, 64 megahertz, which I guess you could try. I don't know, like see what happens. Your voltage will relate a little bit to that because at higher voltages you can clock something faster. You have more buffer. Your slew rate doesn't really matter because that's what's stopping you. Actually, what was it that was? Oh, it's because you can. I believe the thing that makes the higher voltage allow you to overclock faster is because you can fill up. You can raise the gates of the transistors faster. Like you're getting past the threshold voltage much faster with higher voltages. Well, it's been a while since I remember why exactly the voltage is tied to the frequency. Maybe I'll look it up. But that's why you can't overclock a microcontroller to 10 times. It's not a heat sink thing.
Okay. How did you do the flat bottom?
Oh, it's just surface mount connectors. So that's why so this one is a through-hole version that I soldered and stuff, so it's got stuff. But this has surface mount connectors that are fully pick and placed. So you can see they got the little legs sticking out. So it's they're surface mount pick and placed on.
Okay. And that's that. 20 minutes on the dot. Exactly what we said
Okay,
we'd do.
great. I'm going to look up the relationship between voltage and frequency. Because it's funny. On the other hand, you'd think the lower the voltage, maybe the less you have to fill up the gate capacitance. So because you don't have to go as you don't have as many coulombs you gotta pump in. But I'm clearly mistaken. So I gotta like remember what it is. It's been a while since I took 6004.
Okay.
I look at my course notes.
All right.
Okay,
That's
that's
another
it.
Desk of Lady Ada.
Fast and Furious. So pick up a Metro from DigiKey for $15. It's a good deal.